So our last part, because we've spent a little bit of time now taking a look at some of the finding angles and our SOHCAHTOA method, here we're going to take a look at how to use what we know with trig to actually find side lengths. So in this case, we have one side length given, so we can't use Pythagorean theorem, but we are given the angle in the problem at 18.9 degrees. So first thing is to then label out what's our opposite, our adjacent, and our hypotenuse. So we have 18.9 for angle P, which means that side P is going to be our opposite side. We have our hypotenuse opposite the right angle, that's side Q, that's going to be our hypotenuse. And then the adjacent side being the side that's next to the angle, that's not the hypotenuse. So now we can solve for either one of them. We just need to pick the right trig function to do it. So if we take a look at side length P first, or side P, we see that it's opposite and we're given the adjacent. So opposite over adjacent. We've got our acronym SOHCAHTOA. And so opposite over adjacent looks like it's going to be tan. So tan of our angle P, so tan of P is equal to opposite over adjacent. Now in this case, we actually know what angle P is. So I'm going to write that in. Tan of 18.9 degrees is equal to, now the opposite is P, and the adjacent we know is 35, and specifically 35 centimeters. Now, in order to solve for P here, we actually have to do a little bit of rearranging here, and it's not very much. Basically, if the letter is on the top and we're looking to solve for that variable, we need to multiply by the bottom part. So multiply by 35 on the top on both. Now what that means is that P is equal to 35 centimeters times the tan value of 18.9 degrees. So let's just kind of break this apart into smaller pieces, I guess. So P is equal to, I've got 35 times tan of 18.9. So I'm going to do the tan of 18.9 first. Now I don't need the second function button here because I'm given the angle. So tan of 18.9, I have 35 centimeters multiplied by the ratio that this gives me, and I'm going to write out the first four decimal places, 0.342, and then I'm going to round the last one. It's a 3, but the next digit's a 7, so I'm going to round it to a 4. And then I'm going to multiply that value by the 35 centimeters, and I find that P is equal to 11.98 centimeters. So that's how I can use my side lengths to kind of figure out what this is. And really, if the letter's on the bottom and I'm solving for it, it's the same setup again. I just had a division instead of a multiplication. Okay, but finding the side lengths is the same as finding angles. It's just we don't need that second function button here because we're given the angle. So let's take a look at the other one. If I'm finding Q, I'm not adjusting any of my reference angles because I have the same one, but now I have adjacent and hypotenuse. So in this case, adjacent and hypotenuse looks like it's going to be cos. So I have the cosine of 18.9 degrees is equal to the adjacent, which is 35 centimeters, over Q. Now here Q is on the bottom. See, in the first example where P was on the top. But now my variable's on the bottom. I'm going to do the same step. I'm going to multiply by Q first on the top on both sides, so times Q and times Q. And I'm going to have Q times the cosine of 18.9 degrees is equal to 35 centimeters. Then now here I could multiply when I was solving for Q, or solving for P in the other one, sorry. But in Q in this case I have to divide by the cosine of 18.9 so I can get Q by itself. 18.9 degrees. So really Q is equal to 35 centimeters divided by the cosine of 18.9 degrees. So there's a little bit of an extra step when Q is on the bottom. So if I take my calculator now and take 35 divided by the cosine of 18.9, then I get 36.99 degrees, or 99 centimeters, sorry, which is really close to say that this thing's 37 centimeters. So if your calculator doesn't store the digits on the top, you may have to hit the cos of 18.9 first and get that 4-digit decimal. So the cosine of 18.9 works out to be just kind of on the side if you had to do it. The cosine of 18.9 works out to be 0.9461. And so then you could take 35 divided by 0.9461, and you're getting that 36.99 that I got earlier. So it just depends how your calculator stores numbers. But finding side lengths is very similar to finding angles. You're setting up all the same reference angles. You just don't need that second function button, and you're solving for a variable instead of solving for an angle. So I do have a worksheet that goes along with this stuff, and let me know if you have any questions.